Some of the special conditional statements are the converse, inverse, and contrapositive. So, let's say we have this given conditional statement, P implies Q. If we want to find the converse of it, we will actually have to switch the positions of P and Q, hence we get the converse Q implies P. If we would like to get the inverse of the conditional statement, we will have to negate each of the simple propositions P and Q and imply them as not P implies not Q. To get the contrapositive of the conditional statement, we would have to negate the simple propositions and then have it as not Q implies not P. So the converse, inverse, and contrapositive are propositional forms of the conditional statement but basing it from an original conditional statement. So, say for example, we have the conditional statement if x equals 1, then x squared equals 1. So, if we're going to have it as the conditional statement P implies Q, we can say that x equals 1 is our statement P, and x squared equals 1 is our statement Q. Now, how will we now write the converse, inverse, and the contrapositive of this specific conditional statement? Pause the video and try it out following the symbolic statements here. Alright, so let's see. If we want to write the converse of this conditional statement, then we would have Q here, then P on the other side. So therefore, if x squared equals 1, then x equals 1. On the other hand, if we want to write the inverse, we would have to negate statement P and statement Q. It would be if x is not equal to 1, which is the negation of P. Let's write it down. Maybe here that the negation of P would be x is not equal to 1. And the negation of Q would be x squared is not equal to 1. So therefore, if we're going to have this as the inverse, we will have this statement here that if x is not equal to 1, then x squared is not equal to 1. Using the same statements for the contrapositive, we would have if x squared is not equal to 1, then x is not equal to 1. So these are the converse, inverse, and contrapositive of our original conditional statement. And of course, since these are propositional forms, we have to check its truth values. So we have here a truth table showing the truth values for P and Q. P and P implies Q, or if P then Q. Basing it on the truth tables that we had before, especially for here, the implication, and for the negations, pause the video and try to fill out this table to see what would be the truth values for the converse, inverse, and contrapositive. Alright, so filling this one out, not P, we will just have to reverse these, so I will have 0, 0, 1, 1. Not Q, I would have 0 because that's not 1, not 0 is 1, 0, 1. So now combining these ones, I can now move on to the other columns of this truth table. So we would have here 1, Q implies P, so we're going to go in that direction. So 1 implies 1, that is 1. 0, that implies false, that implies true is true. True that implies false is false. And false that implies false is true. So that is for our converse. For the inverse, here, we will look at this one here. False that implies false, we know that is true. False that implies true is also true. True that implies false is false. And true that implies true is true. And lastly, for our contrapositive, we will go that way. False that implies false is true. True that implies false is false. False that implies true is true. And true that implies true is true. Do you notice something in our table? As you can see, the original conditional rather and the contrapositive would have similar truth values given these situations. Similarly, the converse and the inverse would have similar truth values with the given situations. So we can say that the converse and the inverse, the original, conditional, and the contrapositive would have similar truth values with our given situations. And the last of our propositional forms is the biconditional statement. It is read as P if and only if Q, or P is equivalent to Q. We have this symbol here, a double arrow, or we can use this one, which is actually a symbol of equivalence. Or we can also have PIFF, which would mean if and only if Q. So for example, we say proposition P is lines are perpendicular, proposition Q is lines form right angles. Therefore, P if and only if Q would mean lines are perpendicular if and only if they form right angles. So, to see their truth values, here we have, if a statement is true and another statement is true, true if and only if true is true. True if and only if false, that is false. False if and only if true, that is false. And false if and only if false is true. So, based on this one, we can say that a biconditional statement will be true if its simple propositions would have the same truth values. That's how we're going to have in our biconditional statement. And those are our different propositional forms. Let's just write them down. That our different propositional forms are our negation, conjunction, disjunction, the conditional statement or the implication, which has converse, inverse, and contrapositive, and we have our biconditional statement. Here are our propositional forms.